So this is video 4.1c, trigonometry, graphs of the sine and cosine functions, and we're going to talk a little bit more about some examples here. Now I had mentioned earlier the idea of period and also mentioned the idea of amplitude. So if you remember, period is the distance from here to where it starts repeating itself. So the period is always along the x-axis, how long it takes to start repeating itself, so 2 pi. The amplitude, again, is how far up it went from that little center section there, in this case the x-axis, so it went up 2. In this red one, it went up 1 before it went back down, and it went down to -1 until it started going back up again. So that's the amplitude. The amplitude is found by looking at the number in front of the sign. So if we have in our standard form y equals sine of x, which is the red one, it goes up at the highest point 1, lowest point -1, period is 2 pi. Well, if we put a number in front of sine, now look what happens to my amplitude. It goes up that number. It goes up to 2 and then back down and up. So notice the period did not change. It still goes through 1 period in 2 pi. It just goes up higher and then down lower before it repeats itself. So if I had like a period or an amplitude of 3, exactly the same, it would just be elongated. It would go up higher. So the amplitude then is the average, or the difference, or half the difference between its highest point, maximum, and its minimum point. So the highest point is 3, lowest point is 3, add those two together, you get 6, take half of that, you get 3, and that's your amplitude. Or you can just look at this and go 1, 2, 3, there's my amplitude. So that's what we've got here, and it's called, the format is called y equals a number times the sine of x. So when you have a number in front of sine, that is going to determine how high and how low your graph goes. Now when I did this, I did it with the sine, but the cosine is the exact same way. If you have a number in front of your cosine, same thing will happen. That number, that a, that integer that goes there, will be how high the amplitude is. So that's what we've got there in just that little section. This next section that we're going to talk about is what happens if we have, again, the standard form of the equation like that. Let's say that we put a number here. We put a number in front of the x and after the sign. Alright, so in fact the book calls it the letter B, so let's stick with that. So what's going to happen to the shape of this drawing of the sine wave if we put a number in front of the x instead of in front of the sign? And pretty soon we'll be doing both, but right now let's just look at a number between the word sign and the x value. So notice what happens. Here is our general, y equals the sine of x. That's our red line, so it starts here and goes through to 2 pi. And then we put a 2 in front of the x. And notice what happens. We've got the same shape. Notice the amplitude in front of this is 1 and the one in front of this is 1. There's no letter there or number, so it's assumed to be 1, so it's just going to go up to 1. But when we put a 2 there, look how many periods we go through when we get to 2 pi. So our normal red takes us to 2 pi for one period, but when we put a 2 there, it doubles how many periods we have in 2 pi, or we have one period in half the time, or half the space, that a regular one has with no number in front of there. So this 2 means that we get through here in half the time. We do a period in half the time. So instead of a period in 2 pi, we do a period in half of that, which is 1 pi. Okay, so I'd like to say it's as easy as that as far as figuring it out. It's easy to explain it, how that works, but we're going to run into some things like y equals the cosine of 2/3 x, and maybe they want us to graph that. So this is going to be a little bit different. Sure, we just take half of that, or we take 2/3 of 2 pi, and that would give us how far it is in a period. But how do we graph all these points along our XY axis in order to actually draw that? So we're going to go into that in this next section.